This is an American F-15E fighter jet, while on a mission in Iran, to ensure the kinetic energy of the bunker buster bomb was sufficient to penetrate underground shelters. They were forced to ascend, leaving the cover of the valley. This moment of exposure was immediately targeted and hit by a surface-to-air missile. The hydraulic system subsequently failed, and in the final seconds before the aircraft crashed uncontrollably, the pilot decisively pulled the ring, activating the ejection seat, a complex life-saving procedure. Although this entire ejection process takes only 0.3 seconds, it is extremely dangerous for the pilot. At the moment the seat ejects, the pilot experiences a gravitational load of approximately 15 gigaseconds. If the limbs are not properly protected, the immense air pressure impact can easily cause fractures. Therefore, in such a life-threatening emergency, the pilot will decisively pull the ejection lever. This lever is usually located between your legs, or there may be one above the head. It is connected to the safety lock via rods and hinges, specifically designed to determine if you are truly in distress, or if it was an accidental activation. Under normal circumstances it locks the system, but once an emergency is confirmed, it instantly activates the ignition device, and simultaneously engages the restraint system, providing physical support to the body. At this point the leg restraints tighten rapidly, and the arm restraints are also activated, protecting the limbs from high-speed airflow damage. In addition, the headrest rises to support the neck, and the airspeed monitoring device is also activated simultaneously. As soon as the pilot is in the correct position, the ignition device begins to operate. The ejection lever activates the firing pin, striking a compressed spring. The spring then strikes the primer charge, initiating a small explosion. The principle is identical to firing a bullet, except that the gas pulse generated here is directed through a conduit to the sequencer. The sequencer can be understood as a distributor that simultaneously activates three systems. At this point the pilot is still protected by the canopy. The sequencer first sends a signal to the canopy's explosive bolts, igniting pyrotechnic charges to produce high-pressure gas. This gas, utilizing the two shockwaves generated by the explosion, instantly blows open the connecting bolts, causing the canopy to be rapidly blown away by the airflow. Once the canopy is gone, a second slightly delayed gas pulse is transmitted to the ejection system. This is to prevent the pilot from colliding with the canopy, which has not yet flown far. Additionally, the back of the seat here is mounted on two rails. Multiple telescoping pistons within the ejection tube provide thrust. When the sequencer sends the pulse, the gas produced by the primer explosion compresses the piston at the bottom of the ejection tube. Once the gas pressure reaches a certain level, the ejection lock disengages the main system. The piston moves upward under high-pressure propulsion, simultaneously triggering the secondary charge to produce even greater thrust. As the pistons extend sequentially, the seat can smoothly ascend along the rails. This entire sequence is completed within 0.2 seconds of pulling the lever. The generated acceleration can reach 12 to 20 gigaseconds. Simply put, if you weigh 80 kilograms, you would feel a force of 1,600 kilograms pressing down on you at that moment. This is also when the pilot is most likely to be injured. This is also when pilots are most vulnerable. Now when the seat is completely off its track, the solid rocket engine at the bottom will immediately take over, generating immense thrust within 0.2 to 0.3 seconds to propel the seat high into